Hey everybody, welcome back to the Flat Thunder channel. My name's Andy, and this is a big pile of heavy wall tubing. This is 3" by 3" by 3/8 inch thick wall square tubing. Then we have ourselves some 1/4 inch thick flat plate that we're going to use as end caps on this. This is going to be the subframe fabrication for the crane on good old Margaret. Right now, we got to fire up the old buzz box stick welder and see if we can melt metal together with it. I haven't really used this one. This is one of Grandpa's old welder that we obtained from him. He bought it at an auction a long time ago and never used it, and it sat in my garage where I never used it until now. Let's see what happens. Here we go. You may have seen this old buzz box or tombstone welder. People refer to them as many different things. Kicking around the garage previously. I turned it on once since then, just to make sure it actually welds. Test welded a couple pieces, but nothing major. So it will weld. Operator error is probably a big problem. And you may recognize this rod holder with that extinguisher. That came off of the Lincoln Ranger 8. But let's get this thing dialed up and see what we can do here. So just a little better idea of what this is actually going to do. We're going to make basically a rectangular structure where these are going to run the length of the frame, and then those over there are going to tie the two together. And we got this big open end here and our flat plate. Basically just cap her off. I switched over to some 6013 rod that's 3/32 in diameter. This will allow me to tack these on there a little bit easier than my bigger 1/8 inch rod. Got a nice solid weld there, and I'm really happy. If we can make them all look that good, that would be great. So Grandpa's welder, it will weld. Now I just got to go ahead and get all the rest of them welded up, and then we'll start forming up the structure. So we're starting to frame this thing up. It's getting a little smoky in here. We're gonna have to open the door pretty soon, get some of these fumes out of here. But it's starting to take shape. I'll take you down here and show you a little bit more about what it is. More or less, it's just a rectangle. So these longer parts that we're putting caps on are gonna sit on the frame, and then it's got crossbars to connect the two halves. So we got it all laid out here. We just gotta tack the back tube in, and then we're going to start flipping it so we can weld in all the flat position. Obviously you want to make sure it's nice and square. And this is what is referred to as a subframe. So we'll get this tacked in here, and start flipping it. That one up there is already tacked. Tack that, flip it, weld, keep welding all the way in the down position, and we'll have ourselves a subframe. Well, the paint's still drying, dry to the touch. We got the truck all fired up, we got the crane all tripoded. We're gonna take this out there, lift the crane up off the truck and try to slide this bad boy underneath the crane, in between the crane and the truck. Here we go. Hey everybody, good morning. It's a nice brisk morning out here. We're as cold as it's going to get today. It's only supposed to get warmer. It's supposed to get up to 44 degrees Fahrenheit. Looking at 28 now. Perfect weather for all that condensate to start forming in the big old beard mesh here. We're back working on the crane. I don't really know if I explained it or not previously, but that metal fabrication we're building was a subframe to go in between the base of the crane and the frame of the truck. Now, depending on what I showed you in the video, we welded the subframe out. We got it positioned underneath the crane by tripoding the crane again, and we're trying to manipulate the crane around to put it on square and shift it to the left and the right, because it was 6 inches that way from the original placement. I believe we got it left to right good enough. The subframe's in there, but we didn't get the tie bolts in. We need to put some bolts in to fasten it down. And we're having some trouble positioning the subframe and the crane a little bit. Largely because we're trying to do it the quick and easy way, and that never works. At least not in this case. I broke down and I bought the correct mounting hardware. These little channels are supposed to affix to the frame and then hold the subframe in position. Because what we were dealing with, we'd move the crane and then the subframe move, or we'd move the subframe and then the crane would move, vice versa. So we need to get the frame drilled, get these little channels bolted into the frame and then welded to the subframe, and then we can start positioning the crane. It's just slightly crooked. This is a subframe we welded out on the weld bench in there. It goes all the way underneath the bottom of the crane. Did have to put a shim plate in here because I was originally trying to place it all back behind this outer wrap. Unfortunately, I couldn't do that because of placement of the cross member. Ended up shifting it forward. This is going to give us a good representation of where the crane and the cab will go when it's actually installed. This is just a temporary installation, again, so we can use it. There's what those are going to look like. Just need to pop a bolt in the frame, or pop a hole in the frame so we can put a bolt in and then weld around that. There we go. I switched over to the 11/16. This is where it's going to get really interesting. Definitely going to need the grab handle for this one. We're through. If you're up here, you would have had a better image. This is a laminated frame, and when you break through to the different sections of the frame, you get a massive pile of rust, dust, and debris and stuff that shoots out, and that just destroys the bit. So I had to go and do a homemade sharpening on that. Not the greatest, but made it cut again. I was over here drilling this hole. I noticed this bottom strap. This is part of the Farmer Special that attaches the front original frame to that outer, heavier laminated frame. It is just rust jacked all the heckin' back. It actually broke the weld that they have on here, but this is all jacked down and twisted out. When we put our tie bolts in, it's going to squeeze that back up. So we're going to try to trip that out of there using our new Ingersoll Rand air hammer. I always wanted one of these, and now I finally have an air compressor that'll run it. Crap out of there. Well, I think that's about as good as we're going to get. That part we were pounding on there, I believe, is a weld from the inside here to the bottom flange on this bar. But we got it all cleaned out pretty good, at least where the tie bolts are going to go. This will all be sucked up tight once our crane bolts are put in. So we got the hole on the other side. We got this hole. We need to drill one hole back here and one hole on the other side, and then we can get our subframe welded to our retainer pieces. Here she is, straight out of China, my Nico digital torque adapter. This basically goes in between the wrench and your socket, and it will monitor the torque. Comes in this little blow molded case, kind of nice, and actually clips. Here she is. So you turn her on, and it says that means peak. So what you're going to do is adjust. That's probably not, that's the wrong way. We need to adjust up. Just up to your desired torque range. It'll flash the value for a minute, and then it'll go back to 0. It'll go back to 0, and then you start applying torque. When it gets close to the torque, a light will flash and it'll beep, and then when you reach full torque, I believe it'll go solid, and then it'll record the peak value that you reached. So, well, unless the old interwebs is lying to me, which has happened before, the specification for these tie bolts, as I understand, is 450 Newton meters, and the good old Google machine says that's 330 foot-pounds, which seems light for a bolt of this size. Maybe the fine pitch and the lead angle makes it clamp more with the lower torque. Standard bolt would be quite a bit more, so I don't think they're torquing it to yield, at least as far as I can tell. So what the heck, let's just go 330. We got her set to 330. We're gonna cram this thing on there and see what she does. $220. Oh, 220. Fudge. $230. Come on, be in the 300s. 250. Winded. Uh-oh. That's a winning ticket. Complete dirt to do moment. If you guys weren't screaming at the TV, you should have been. Why didn't you tell me? Sitting there spinning this thing forever. It's getting tighter, but just ever so slowly making a noise. I didn't move the wrench over. Stupid. We got on the right side now, and we're approaching the torque a whole lot faster. I'm going to set you up here by the torque meter so you can see how she works. The unit automatically turns off, which is a good thing. We're remembers the previous sitting, so we're ready to rock and roll. That beep means we're 20%. That's it. $347.7 is what we got. Call that good. Move on to the other side. Well, we got it all torqued down. It took way too long. I had never imagined it would take that long, but here we are, we got it. Right now we're gonna back it up. We're gonna set up the stabilizers and we're gonna unfold this thing. I have yet to unfold this thing to its max capacity. We just unfolded it in that short little envelope to manipulate it and work it around. Now we can actually open her up. Here we go.